Hello, this is a short video in which I will do my best to describe or give you a little bit of an intro to data analysis, to data. And we'll start off with this slide which kind of sums it up, where what we're interested in when we're doing data analysis is finding order in disorder. And what you're looking at is not order. The statistician's role in the research process is complex, and at times all they do is analyze data. They don't do anything else. But a good research design will involve the statistician from the beginning in order to make sure that the data collected is going to tell the story that they want to be told, or answer the question that they are posing. So the statistician's role is sometimes a truth teller to the researcher. So today's on the today's menu, we're going to look at data, and it comes from the Latin word datum. And I kind of googled around, and in many languages, there's some version of date, dare, which are either gifts given. Many European languages where there's so you can hear that sound, which is surprising. Now what I'm going to try to pitch to you today, that raw data is sort of like raw food. So you don't necessarily finish with raw data, just like you would not finish with raw food. You got to do something to it. And so here we're back to this. Now this is not raw. Well, I guess it could be raw data, but it already has some work been done to it. And in the same way as this fish, so there's a sketch of a fish to the right there, that's raw food. But the bottom line is somebody has to go out and collect it, and somebody has to intend to collect that particular data or that particular food. So you don't just go out and grab something out of the ocean, and the same way you just don't go out and grab some random data. And then once you have the data, the raw data, you need to clean it and you need to prepare it, and there's a whole process involved. And so intent, I think, is this key word that I want to emphasize here, because it's an intentional act. It's not something that just kind of happens haphazardly. A good analysis of data is sort of like good cooking. It brings out the best and truest story, or the truest flavors. It's not necessarily the best story or the fanciest or the best looking, but we're interested in getting the real true flavors of the fish, so or of what the data is telling us. So we're not interested in dousing it in hot sauce and then not tasting what we're eating at all. All data is not the same, so let's take a look here. So to the left you have what's called measurement data. So we have final marks from an actual course that I taught a while ago, and where the passing mark was a 60, and so you can see here those folks did not pass the course, and from here on the rest of the folks did pass the course. I just grabbed a snapshot, and so we have measurement data here, and then to the right we call it categorical, and which is displayed as a histogram, and to the right we have categorical data, which is a set of classifications. And so all you do is you note 0 for did not pass and yes for pass. And so that gets displayed quite a bit differently because you don't have so many different options. You only have two options here, just a yes and a no. Data analysis. We need to listen. Now this is ironic because what we do mostly with data is we look at visual and numerical representations, which are not anything like listening. So we have to kind of tweak things around, and then as we're tweaking things around, we're listening and paying attention. There's a lot of paying attention and noticing, and the more experience you have, the more sensitive you are to important and surprising developments. And we're going to look at two types of data analysis. This is not the way courses are set up typically. We're going to look at non-inferential and inferential. And so they do two different things. And again, there's an intent to it. So depending on what the researcher is interested in, the questions posed may be non-inferential or maybe inferential. And most studies, and especially in the health sciences, are interested in inferential reasoning and inferential research, partly because what we want to do, for example, with vaccinations, we want to run the vaccinations on 10,000 or 20,000 people, and then we want to be able to say, I think this vaccine is safe, it will work, and it will not kill people. And what we see, so I've broken it down here, we have non-inferential and inferential stats here, and that is part of the process. So that's most of the work that we're going to be doing in this course will be using non-inferential and inferential statistics. And so first part of the course, for the most part, everything will be broken down into starting from non-inferential, then working towards inferential statistics. And the last little bit, I want you to pay attention to this and spend some time thinking about this characterization of precision and accuracy with measurements. I took this from shmula.com, so I just want to put a shout out to them. And again, true value, accuracy. So precision, we oftentimes, or often as human nature, we value precision over accuracy. So just because you have very precise shots, they're all very close together, if you miss the target, it doesn't matter. If you're not measuring what you really want to be measuring, then you're not accurate. Sometimes it's better to be less precise and accurate. But because we're doing inductive research, inductive reasoning for the most part, we don't know whether our values are accurate when we do research. And so that's part of the real difficulty in research, which we're not going to address right now, but down the line, we'll get to that. Thank you for watching. See you soon.